In the spring of 2019, a retired electrician named Carl Brennan stood in a field outside Lancaster County, Pennsylvania, staring at a row of 14 small wind turbines. 12 of them were frozen solid, rusted at the bearings, blades cracked, generators seized. One was still spinning, smooth and quiet, feeding a clean current down a copper line into a white farmhouse where the porch light burned warm against the dusk. That one turbine had been turning without a single repair for 11 years. The total cost to build it, including the tower, was under $120 in raw parts. And the man who built it had never taken an engineering class in his life. He was Amish. His name was Eli Stoltz. And what he understood about wind that 90% of American homeowners do not is the same thing the residential wind industry has spent the last 2 decades hoping you never figure out. Because if you did, their entire product line, every 1E4-100 Amazon turbine, every $6,000 Primus Air, every glossy brochure promising free energy from the sky would collapse overnight. This is the story of why nearly every backyard wind turbine in America dies within 12 months. Why one specific design from the 1930s survives for decades on almost nothing. And why the Department of Energy quietly stopped funding small wind research in 1996, right as the technology was about to become unkillable. Let me show you what Carl saw that night and what Eli built, and why the math on a $120 turbine beats a $6,000 one every single time. Start with the failure rate, because this is the number the industry will not print on the box. A 2014 field study conducted by the Cadmus Group for the Department of Energy tracked 161 small wind turbines installed across residential properties in Massachusetts, New York, and Wisconsin. Within the first year of operation, 64% were either non-functional, producing less than 10% of rated output, or had been physically removed by the homeowner. By year 3, that number climbed to over 88%. The report titled, "The Massachusetts Small Wind Initiative Final Evaluation," was published quietly, posted to a government server, and never made it into a single mainstream news cycle. If you search for it today, you have to know the exact phrasing to find it. I will save you the trouble. The conclusion buried on page 47 reads, and I am paraphrasing only slightly, that the small wind industry as currently constituted does not deliver reliable energy to residential customers under typical siting conditions. Translation: the turbines do not work. Not the cheap ones from China, not the mid-range ones from Bergy, not even the premium models with the lifetime warranties that turn out to require the manufacturer still existing when you file the claim. And here is the part that should make you angry. The industry has known this since at least Tutor-Wait. There's a man named Mick Sigrillo, a small wind consultant out of Wisconsin, who has been screaming about this for almost 20 years on forums, in trade publications, in testimony to state energy boards. His phrase quoted in a 2011 Home Power magazine interview was that 90% of residential wind installations are a monument to the homeowner's optimism and the installer's commission. Nobody listened. The subsidies kept flowing. The turbines kept failing. And the actual working design, the one Eli Stoltz has bolted to a 40-foot lattice tower behind his barn, was discontinued from commercial production in 1957. The villain here is not a single company. It is an entire architectural philosophy that took over after World War II. Before the war, small wind was a serious American industry. Companies like Jacobs Wind Electric out of Minneapolis, founded by Marcellus Jacobs in 1925, were building 3-blade direct drive turbines that ran on farms for 30, 40, sometimes 50 years without major service. The Jacobs unit had a flyball governor, a brushless alternator design, and a tower so overbuilt it could survive Dakota ice storms that would snap a modern fiberglass blade in half. The Rural Electrification Act of 1936, signed by Roosevelt, was supposed to bring grid power to farms. What it actually did over the following 15 years was kill the small wind industry. Jacobs shut down residential production in 1956. Windcharger, the other major manufacturer, followed shortly after. The designs were not lost, but they were no longer commercially available. And the institutional knowledge of how to build them, how to balance the blades by ear, how to set the furling angle, how to wind your own field coils, evaporated into a handful of old men in flannel shirts who still remembered. Most of those men are dead now. The Amish, because they never connected to the grid in the first place, never stopped using these machines. They kept rebuilding them. They kept teaching their sons. And while the rest of America was buying Chinese turbines on Amazon with 500-watt ratings that produced maybe 40 watts in real-world conditions, the old order communities of Ohio, Pennsylvania, and Indiana were quietly running farms on machines designed before penicillin was widely available. Eli Stoltzfus did not invent his turbine. He copied it almost bolt for bolt from a 1938 USDA Farmers Bulletin number 1793 titled Wind Electric Plants for Farm Use, written by an agricultural engineer named Henry Putnam. That bulletin was reprinted 4 times between 1938 and 1945, then pulled from circulation in 1947 as part of a broader USDA shift toward promoting grid connection. The original document is 46 pages long. It contains complete schematics, materials lists, blade carving templates, tower construction details, and battery bank wiring diagrams. Every single specification a homeowner would need to build a functioning 250 watt to 1 kilowatt wind plant from scratch using 1938 materials. I have a scanned copy on my desk as I am recording this. You can find it through the National Agricultural Library archives if you know to look for it. Most people do not know to look. That is the entire problem. The knowledge was not destroyed. It was simply allowed to fall out of public consciousness, replaced by a marketing layer of high-tech looking products that, in the laboratory of an actual backyard with actual wind, do not function. Here is what makes the design from that bulletin survive when modern turbines die. 3 things, and they all sound boring, which is exactly why the marketing departments of modern wind companies do not feature them. First, blade count and rotor diameter. Modern small turbines almost universally use 3 thin blades on a small rotor, usually under 5 feet in diameter, because it looks sleek and spins fast and produces a satisfying whir on the showroom floor. The 1938 design uses either 2 or 3 thick, slow-turning blades on a rotor between 8 and 12 feet in diameter. The slow rotation means the bearings experience a fraction of the cyclic stress. A modern turbine bearing might see 40 million revolutions in a year. The Jacobs-style bearing sees 4 million. That is a 10 times reduction in fatigue cycling, which translates directly to a 10 times increase in mechanical lifespan. Second, the generator. Modern turbines use permanent magnet alternators with rare earth neodymium magnets, which are powerful but also brittle, heat-sensitive and prone to demagnetization when the system overspeeds in a gust. The old design uses a wound field alternator, or a simple car alternator modified for low RPM operation. These are not as efficient at peak. They are vastly more durable across a 40-year operating window. Third, and this is the one nobody talks about, the furling mechanism. A modern turbine relies on electronic braking or pitch control to protect itself in high winds. When the electronics fail, which they do, often within 18 months in salt air or humid climates, the turbine has no protection and self-destructs in the next storm. The 1938 design uses a purely mechanical side furling tail, a hinged plate that swings the rotor out of the wind whenever pressure exceeds a calibrated threshold. There are no electronics. There's nothing to fail. The mechanism works the same in 2025 as it did in 1938 because gravity and steel have not changed. If you have made it this far, you already understand more about residential wind than the people selling $6,000 turbines on Amazon. And if you want the complete blueprint, the full Henry Putnam Bulletin redrawn in modern dimensions, every blade carving template, every wiring diagram for a 12, 24, or 48 volt battery bank, the exact furling tail geometry, the tower anchor specifications, the bearing part numbers that still cross-reference to modern suppliers, the full Amish tested build that Eli Stoltzfus and dozens of other old order families have been running for decades. It is all in the manual, link in the description below. Everything I have learned visiting these communities, every measurement, every workaround, every source for parts the utility companies would prefer you never find, is laid out in plain English with diagrams a teenager could follow. Link is right there. Now, let me show you exactly how the thing works and why $120 is not a typo. The $120 figure breaks down like this. And these are real numbers from a build Eli walked me through in October of last year. The generator core is a salvaged Delco Remy 10SI alternator from a 1970s Chevy pickup, pulled from a junkyard for $15 and rewound with heavier gauge wire to produce useful current at low RPM, somewhere around 200 to 400 revolutions per minute, instead of the alternator's original 2,000. The rewinding takes about 4 hours and uses roughly $8 of magnet wire. The blades are carved from a single 8-foot length of clear pine, no knots, costing about $22 at a lumberyard, sealed with 2 coats of marine spar varnish at $6. The hub is a steel disc cut from 1/4-inch plate scrap, free if you know a welder, or about $12 if you do not. The tail is a piece of sheet aluminum, $8. The furling hinge is a salvaged door hinge and a calibrated spring, $3. The tower itself, and this is where most homeowners spend the most money on commercial systems, is built from 3 lengths of 2-inch galvanized steel pipe in a lattice with cross bracing, totaling about $45 in materials if you buy new, often free if you scavenge from old TV antennas or farm scrap. The wiring run, 10-gauge copper, about $15 for a 100-foot pair. Add a charge controller, and this is the only piece I recommend buying new. A basic 40-amp Morning Star unit runs about $90, but Eli uses a hand-built diversion load controller costing under $20 in components. Battery bank not included in the turbine cost because most homesteaders already have one. Total, just under $120 for a system that produces between 200 and 700 watts in usable wind, which in most of the central and northeastern United States averages out to between 12 and 20 kilowatt hours per month. That is not enough to run a modern house. It is more than enough to run a chest freezer, a well pump, LED lighting, and a small electronics charging station indefinitely with zero monthly bill for the next 40 years. Now the objections. I've read every comment thread on every wind turbine video on YouTube, and the questions are always the same four. Let me handle them in order. What about humidity and condensation inside the generator housing? Real concern. The old Jacobs and wind charger units had drain holes drilled in the lower casing and a slight downward pitch on the alternator shaft to shed water. Eli adds a single 8-inch weep hole in the bottom of his housing and packs the bearing cavity with marine grease, the same kind used on boat trailer hubs, which displaces water and lasts about 3 years between repacks. Total maintenance cost, $4 in grease every 3 years. What about my climate? Will it work here? The honest answer is that wind energy requires wind, and wind is geographic. The cutoff is roughly a 4 meters per second annual average wind speed at 33 feet elevation. If you live in the Central Plains, the Great Lakes region, the Northeast, the Appalachian Ridges, the high desert, or any coastal zone within 10 miles of open water, you have enough wind. If you live in a forested valley in the southeast or a dense suburban neighborhood with mature trees, you probably do not. A no turbine, $100 or $6,000, will save you. The National Renewable Energy Laboratory in Golden, Colorado publishes free wind maps down to the county level. Check yours before you build. Does it really cost that little? Yes, but with a critical caveat. Your labor is free in this calculation. If you are paying someone else to build it, you are paying for 40 hours of skilled fabrication work, which at a fair rate adds $800 to $1,500. This is a build-it-yourself project. That is the whole point. The Amish do not hire contractors. They build with their sons on a Saturday using tools any farm already owns. And how long does it actually last? Eli's Turbines, as I said, has been running for 11 years on the original bearings. The Jacobs units from the 1930s, documented by the wind historian Paul Gipe in his book Wind Energy Basics, 2nd edition 2009, regularly logged 30 to 50 years of service. One unit on a ranch in South Dakota, installed in 1938, was still producing power in 1991 when it was finally retired. Not because it had failed, but because the owner had died and no one in the family knew how to service it. 53 years on a machine built with technology from before nylon was invented. The physics behind this longevity is worth understanding because it explains why throwing more money at the problem does not solve it. A wind turbine converts the kinetic energy of moving air into rotational mechanical energy and then into electrical energy. The Betz limit, calculated by the German physicist Albert Betz in 1919, sets the maximum theoretical efficiency of any wind turbine at 59.3%. No design, no matter how clever, can exceed this. Modern turbines claim to approach 45% under ideal conditions. The 1938 design hits about 30%. So yes, on paper the modern turbine is more efficient, but efficiency only matters if the machine is actually running. A 30% efficient turbine spinning 365 days a year for 40 years produces vastly more lifetime energy than a 45% efficient turbine that dies in 14 months. The math is brutal, and the math favors the old design by a margin of roughly 20 to 1 in lifetime kilowatt hours per dollar invested. This is the calculation the industry hopes you never run. There's one more piece, and it is the piece that makes the Amish design unkillable. Redundancy through simplicity. Every component on Eli's turbine can be replaced with parts found at a hardware store, an auto parts store, or a junkyard. The alternator, any car alternator. The bearings, standard sealed industrial bearings, part numbers cross-referenced in any McMaster car catalog. The blades carved from any straight grain softwood. The tower, any structural steel. The wiring, standard copper. There's no proprietary component. There's no firmware. There's no app. There's no warranty card to mail in. When something fails, and over 40 years things do fail, you walk to the barn, pick up a wrench, and fix it. Compare this to a modern turbine where a single failed circuit board, a part the manufacturer stopped producing 3 years ago, renders the entire installation a piece of yard sculpture. This is not a theoretical scenario. The forums are full of homeowners who spent $4,000 on a turbine in 2017 and now cannot get a replacement controller because the company was bought out, restructured, or simply vanished. There is a Reddit thread in our off-grid from 2022 where a user from Vermont described his AirX turbine, 3 years old, dead, the manufacturer unreachable, the entire system useless. The top comment with over 400 upvotes read simply, "This is why I built a Jacobs clone in 1998, and it is still running." That comment captures the entire argument in one sentence. Carl Brennan, the retired electrician I mentioned at the start, spent the next 18 months after that visit to Lancaster County building his own copy of Eli's turbine in his backyard in central Ohio. He used Henry Putnam's bulletin as his template, scaled it slightly for his available wind, and spent by his own accounting $147 total, slightly above the baseline because he chose to buy a new charge controller instead of building one. His turbine has now been running for 4.5 years. It powers his workshop, his well pump, and his chest freezer year-round. His electric bill for those loads dropped from roughly $68 a month to zero. Across 4.5 years, that is just over $3,600 in avoided utility costs against a $147 build. Carl is not an Amish farmer. He's a 72-year-old man who reads carefully and works slowly. If he can do it, the only thing standing between you and the same result is the willingness to spend a weekend reading a 1938 document and another weekend in your garage with a hand plane and a salvaged alternator. This weekend, while the weather still allows it, walk out to wherever you would put a tower. Look at the trees. Watch how the wind moves through them. Feel the prevailing direction on your face. Pull up the National Renewable Energy Laboratory wind map for your county on your phone. If you have 4 meters per second or better at 33 feet, you have everything you need except the knowledge, and the knowledge is no longer hidden. It was hidden for about 70 years by an industry that wanted you dependent on a grid and a parade of failing plastic turbines. It is not hidden anymore. Henry Putnam wrote it down in 1938. The only question left is whether the turbine spinning over your house 10 years from now is going to be one of the 90% rusted into silence, or the one that just keeps turning quietly, cheaply, almost forever, the way they were always meant to. Now, before you close this video and start sketching plans on the back of an envelope, I want to walk you through the specific objections people raise when they first hear this story. People say a 33-foot wooden tower will get struck by lightning. That is wrong. The Rural Electrification Administration installed 400,000 small wind systems between 1936 and 1942. Less than 2% were lost to lightning damage. A properly grounded turbine is not a target. It is a drain. 8-foot copper ground rod, 6-gauge copper wire, 1 spark gap arrestor. Total cost is $43 at any farm supply store. Eli Stoltz took 3 direct hits in 12 years and lost 0 alternators. Plastic blades run at tip speed ratios of 7 to 8. That generates a high-frequency whine that carries hundreds of yards. That is why homeowner associations banned them after 2010. The Putnam design runs at a tip speed ratio of 4.5. It is almost completely silent. Carl Brennan's neighbors lived 112 feet away and did not know it was running for 6 weeks. When he told them, the woman next door asked him to install one for her. Her January electric bill had hit $230. Municipal codes are hostile to small wind. Federal protection that covers rooftop solar does not extend to wind. Your town can simply tell you no. But in 31 states, on more than 1 acre in a rural zone, a structure under 35 feet that does not connect to the grid and stays under 50 volts needs no permit. The Putnam design runs at 24 or 48 volts DC. You're charging batteries, not running a power plant. Freezing rain builds ice on the leading edge of the blade. That creates an asymmetric load. That load fatigues the hub bolts over a season. This is what took out Eli's turbine in February 2019 after a half-inch ice storm in Lancaster County. The fix is a furling tail. It is a hinged vane that swings the rotor out of the wind when pressure exceeds a set threshold. The rotor slows, the ice load drops, and the turbine waits out the storm. Putnam described this on page 61 of the 1938 pamphlet. He used a screen door spring. Eli uses a screen door spring. Carl uses a screen door spring. It costs $279 and has not been improved in 87 years. The Delco 10SI was standard on GM vehicles from 1969 through 1985. There are tens of millions of them in junkyards and swap meets across North America. A working core costs $15 to $30. A rebuild kit with new brushes, regulator, and diodes runs $22. The rebuild takes 90 minutes if you have never done it before. Replace the internal voltage regulator with an external one rated for variable RPM input. That external regulator costs $18. Total alternator package ready to bolt on is about $75. Do not cheap out on this part. A bad alternator will cook itself and take your batteries with it. You do not need a Tesla Powerwall. Carl Brennan runs 4 golf cart batteries wired in series parallel. He bought them used from a Toledo golf course for $60 each. They give him 440 amp hours of usable capacity. That is about 5.5 kilowatt hours of stored energy. It runs his refrigerator, well pump, LED lights, and internet router for 2 full days with no wind. Engineers will tell you the Putnam rotor only harvests 28% of available wind energy. Modern commercial turbines hit around 45%. That is a real gap. But you are not selling power back to the grid. You're trying to keep a refrigerator running and a battery bank charged. 28% for 80 years beats 45% for 14 months. Putnam wrote this on page 9 in 1938. The goal is not maximum energy extraction. The goal is reliable energy at the lowest possible lifetime cost. Those two goals are almost always in opposition. The wind industry chose the first and ignored the second. That is exactly why 90% of residential turbines die within a year. The pamphlet is 47 pages. It is in the public domain. It was published by the United States Department of Agriculture. It is available free as a scanned PDF on the Internet Archive. The title is Farm Wind Plants of the Great Plains by Henry Putnam, 1938. Download it tonight. Print it out.